All right, I'm going to go over the questions on relative dating. Take a look at this first diagram here. We see sedimentary rock layers. They've been tilted. We see an igneous intrusion with contact metamorphism here, unconformity, and deposition on top of that. So the sequence, to put that in the right order, we know these had to be deposited first. That means C and D are possible. We take a look over here, we see an igneous intrusion that came next. And you notice how it's truncated. These are all folded. They were originally horizontal. And then we have the unconformity. So we have the igneous intrusion of E, and then we have the uplift and erosion. So the correct order would be letter D for that one. The cross section below shows the 4 rock units, A, B, C, and D. Which one is youngest? This would have been 1, 2, this would have been 3, and this would have been 4. And we don't notice any contact metamorphism up here, so we know this layer did not squeeze in between here. But in any case, the rock unit that is the youngest would be the one that is closest to the top. And with that contact metamorphism, that would be rock layer A, the youngest rock layer. Evidence of tectonic activity in this cross-section is provided by the fact that normally these would be horizontal and they're tilted, and that tilting, that folding, occurs when you have pressure by continents colliding with each other, so that would be letter D. In this next picture we see some rock layers and we have a fault in between them. We know that the oldest rock layer would be at the bottom, so here'd be 1, 2, 3, 4. That would also be true over on that side as well. And after the rock layer, then we have the feature of the fault. So D would have to be the oldest, and that would be letter A would be the correct decision for that. Okay, which event occurred most recently? Well, the formation of A is way at the bottom, so that's probably the first thing that occurred. So this is probably a 1, 2, 3, 4, and then this number 5. You know, these had to come before the igneous intrusion. And then we take a look at that. So the igneous intrusion is over D, so it can't be any of those. We notice the tilting of the sedimentary rocks, but the erosion of the igneous rock exposed at the surface, that would be the last thing to happen. Which rock is the youngest? So the most recent rock, this would be the first thing to happen. This is the sandstone deposition, and I know that this happened after that because I see that this contact metamorphism is along there. So this had to be here first, then this spilled onto the surface, and this might be considered to be an igneous extrusion right there because I don't see any contact metamorphism. And so this would be number 4. This would be the last thing, which makes this symbol right here important. That's shale. So it would be the deposition of the shale right there. This one says, which 2 letters represent the bedrock of the same age? And each one of these is getting progressively younger as I count through here, but you'll notice something about number 4 over here. Number 4 is part of a fold that at one time, before this period of uplift, weathering and erosion, and then subsidence and new deposition, these 2 were once connected to each other. Just extend that out there. And there's our answer. D and H would be the same age. The folding of rock layers G through C was most likely caused by the collision of plates pushing together and squeezing that together. All right, number 9, which feature is represented by symbol A along the edges of the dikes and sills? So here's symbol A. We see it all along here. It's a dike and a sill, and that represents contact metamorphism, areas where the rock was baked as the intrusion moved through. Which rock type is the oldest? So we know that the oldest are things that formed first. I'm going to look on the bottom here, and I'm going to have to make a decision. Is this igneous rock older, or is this older? And what I notice is that contact metamorphism is on this rock right here, which means it must have been here first. So letter D is older. At one time, I did mention to you that most of the rules that we have here for sequencing follow this idea of superposition. But there are times unusual things can happen where an outcrop is extremely overturned. Something happens and it's extremely uncommon. But here's a couple ways that things can, this rule of superposition can be broken. If you take a look at right here in this diagram at letter B right here, we have what's called an overthrust fold. So this fold has just been really overdone here, and what's happened is the fold itself has moved off to the side. And what I did here is I did number the layers. So this would be layer number 1, this would be layer number 2, and this would be layer number 3. So when you look over here, the oldest is at the bottom and the youngest is at the top. But in this box section right here, this layer has actually been thrust over the other 2 layers. So this youngest layer is at the bottom and the oldest layer is actually at the top. And over here in this example, we have a fault in which part of the fault has actually moved up and over this rock over here. And this rock would be number 1. I'm going to say that this rock is number 3. So in this case, I have an older rock over younger rock. And in this case right here, I have some sandstone and an igneous intrusion. The sandstone's above the igneous intrusion, but the igneous intrusion must have happened after. It must be younger, so I have older rock over younger rock. So in which zone is younger rock on top of older rock? It would be zone A. As you can see, I have old, young, and all the other ones here. For whatever reason, folding, or faulting, or an igneous intrusion, I actually have a younger rock underneath the older rock. All right, in this next question, number 12, which order of events occurred at the Tonyia outcrop between formation F of layer F and the beginning of H? So first we had horizontal deposition. So we know I had deposition, and you notice that this whole area has been folded. So I'm moving towards something with folding. Then I see a truncated fold here, which means I have an erosional zone right here. So that's a unconformity, which would be uplift and then some erosion, and then letter H would be subsidence and new deposition. So the best choice here would be letter B. Going back to this. Okay, for this next one, it says the fault in Evanston outcrop is younger than. So in Evanston outcrop, that's over here, the fault cuts through all the rocks here. All these rocks must have been here already. So I'm going to say most likely that's letter D. And which geological process that affected F happened first? So here we see F was faulted. Here we see F was uplifted and eroded. And here we see F was folded. But before any of these could possibly happen, the sediments in F must have been deposited first. All right, so here we have a picture of a volcano area. Here's our igneous intrusion. We have some features in here of an intrusion, a side intrusion there. We've got the volcano, a lot of contact metamorphism. Which statement correctly describes the relative ages of rocks A and C, giving the best supporting answer? So I see that A and C are together over here. See some contact metamorphism. C must have been here first, and then A. So C must be older than A. A must be younger than C, because the contact metamorphism on layer C, I'm going to go with letter D for my choice. A is younger than C because the intrusion of A metamorphosed part of C. The most apparent buried erosional surface is found between which rock layers? What I notice is that over here, these rock layers come up here. I see a fault suddenly truncated, a feature's suddenly truncated. The rocks are tilted here, and they're suddenly truncated. So I would say between D and F, that would be the most likely area in which I have an erosional surface. Which statement gives an accurate age relationship for the bedrock in the cross-section? So we're going to take a look at all these different choices here. Intrusion A is younger than intrusion C. Now intrusion A and C are contacted here, and C makes contact metamorphism on A. That means A was there already, so A is older than C. A had to be there first. Let's take a look at letter B. Intrusion C is younger than B. So intrusion C cuts across B. There's contact metamorphism. Intrusion C is younger than B because it caused the contact metamorphism. There's our correct answer. The other choices, just take a look. Intrusion B is older than A. Let's see. A has contact metamorphism on it from B, so that has to be older. Intrusion C is older than layer E. Intrusion C cuts over E. E had to be there before there, so C is younger. Number 18, what I did here is I numbered the layers, and in this case, this would have been the first deposited layer. But over here we have our igneous intrusion, and we see some contact metamorphism here, which means that layer 2, this layer of sandstone, must have been here, and this must have squeezed in between. So this would be 1, 2, and 3. But in this case, this is again number 1, but this comes up and there's no contact metamorphism here, which means this hadn't been deposited at that time. So this would be 1, 2, 3. And which statement best describes the relative age of each igneous rock formation compared to the overlying bedrock? Let's see, in A, the igneous rock is younger than B. Igneous rock is younger than the sandstone. So that is correct. Yes, it's younger. And it's older. That is correct. That looks good. In A, igneous rock is older than the sandstone. No, the sandstone wasn't there, so that's no good. The younger, no, and no. Okay, so we feel pretty good about number 18. Let's take a look at number 19. Which of these events occurred most recently? Deposition of A. Well, A has some features cut across it. It has an igneous intrusion on top of it. It has a fault. That must have happened early on. Igneous intrusion, the igneous intrusion cuts across here, but it's cut across by this fault here. So the fault had to happen after the igneous intrusion was there. Contact metamorphism happened during the igneous intrusion, but the last thing, the fault cuts across every one of the features mentioned, so there's our answer there. Now, studying this, we have ages over here, and we have an igneous intrusion, which we know has to happen after these rocks were deposited. Had to happen after, because we see the contact metamorphism. We also see that this area is cut off right here. So there is right there, there's an unconformity right there. And then we see that this area was uplifted, eroded, subsided, and we have some new deposition. So when we're asked what's the possible age of rock layer E, since it sits on top of all of these, I know its age has to be younger than 24.6, because 24 that should say 2, I think, 2, yeah. And because it's truncated here, it also means that it has to be less than the 1.6 million years over here. Now, the only choice that fits in between those two is letter B.